All right, good morning, afternoon, or evening, ladies and gentlemen. We're going to go ahead and do reaction forces. This time they're asking me for the horizontal reaction force at joint A. So check this out. I've already preloaded all those dimensions in here. And normally we'd have to draw in our reaction forces, determine our pivot, everything like that. But the only one they're asking me for is the reaction force at A in the X direction, the horizontal reaction force. And the nice thing about this one is um, I don't need to do the reactions for that because they're both vertical reactions. So I typically would do the sum of the moments around A equals 0, solve for the for B in the Y direction, and then use that with sum of forces in the Y. It have to be 0. So I'd look at the 60 down and whatever B is to determine how much A would have to be. But for this one, I can just look at the sum of the forces in the X have to be 0. And you'll notice at D, I've got 145 pounds pushing to the right. So since it's pushing to the right, we count it as positive. We don't worry that it would cause a negative or clockwise moment. The moment is, of course, different than the force. So this forces, right is positive. And that means I have another X direction force, RFAX, and that's it. Those are the only two X direction forces. So I know that I'm going to subtract RFAX, and RFAX is going to be 145 pounds of force. So it's 145. What direction does it go? Well, that one went right, and since I counted as negative, I know that that tells me I have to have it going to the left. That's all there is to this horizontal reaction force. They aren't always like that, but this one worked out really nicely and easily. So thanks for watching. As always, smash that like button, ring that bell, and holler at me in those comments down below. And stay safe, ladies and gentlemen.